to compare linear functions, and we're going to go through the things that we can compare on a graph. Remember, when you're comparing linear functions, we're working with y equals mx plus b. And that's the equation of a line. And we want to be familiar with that format because it helps us identify these key features here. So let's start with graphing. Let's remind ourselves of these key features in graphing. So when we graph a line, we start with our y-intercept here at -4. Okay? Our slope, that's m. That's the m part of our function. Y-intercept is the b. Okay. So our slope is 1/2. We're going to count up 1 and over 2, up 1 and over 2, 1 and over 2, or down and to the left 2. It is not a linear function until we have connected it with a line. Bam, linear function. We also want arrows on both ends because lines go on and on forever. Determine the equation from a set of coordinates. So we've graphed it, we were given an equation and graphed, but we can write an equation as well. So determine the slope using the slope formula. Notice the slope formula is different than the equation of a line. Okay? So find the equation of the line passing through this point here. So I'm going to find the slope first. So I have to, and that's what they said here, determine the slope first. So this is going to be 12 minus 14 all over, oh, I lied. It's going to be 12 minus 10 because it's the y values, right? So 12 minus 10 all over 14 minus 9. Okay, so that's going to give us 2 over, let's see, 9, 10, 11, 12, 13, 14, 5. So that's my slope. Well, I'm going to use the second version here. I'm going to use the second version here and find my y-intercept. So I'm going to say equals x plus. All right, we found my slope. So I'm going to substitute that into the m spot. It's 2/5. I need to find my b value, and I do so actually by substituting. Now, what am I going to substitute? I'm going to substitute an ordered pair. So remember, ordered pairs are x and y, and I can pick either ordered pair. My x is going to go here at 9. My y is going to go here at 10. So that's right, 12 minus 10 is 2, 14 minus 9 is 5. Okay. So I'm going to get 18/5 because 2 times 9 is 18. So 18/5, and it's adding, so I'm going to subtract. So I'm going to say 10 minus 18 divided by 5. And that's going to give me a b value of 6.4. So essentially what I did, and I don't have room for, is I solved for b. I multiplied and I subtracted this over. So the equation of my line is y equals 2/5 x plus 6.4. All right, let's try that one more time. So first step, we use our slope formula. This is going to be -4 minus 2. My x values are -7 minus a -5. This is oftentimes what y'all miss. Sorry, I'm trying to... Okay. Notice that there's a subtraction sign in this problem, so that subtraction sign stays. So this is equal to a -6 over a -7 plus 5, because minus a negative is addition. So this is -6 over a -2, and we're going to get 3. So my slope is equal to 3. So again, we're writing an equation, so I have to go back to my equation here. Equals plus b. I'm going to substitute for the things I know. I found my slope to be 3, so I'm going to substitute that in the m spot. I'm going to use this ordered pair here, so this is going to be -7 equals -4. And I'm going to solve for b. So -21, that's 3 times the -7. Since that's negative, I'm going to add it to the other side. So that's 21 minus 4. So I get b equals 17. So my equation is y equals 3x plus 17. All right, let's look at the next example here. Our next example is being able to write an equation from a graph. So notice we're still looking for slope. We're looking for a rise over run. And our y-intercept is where it crosses the y-axis. So this example is on the next page here. We're going to find 2 good coordinates. And notice that my good coordinates are already highlighted here. Good coordinates means they pass through these crosshairs here. They perfectly line up. Okay. So I have an ordered pair of 0, 3 and an ordered pair of 5, 2. So a couple of things I can do here. I can count the rise of 1, 2, 3, 4, 5, and to the left 5. So that calculated rise over run. So my slope is a -1/5. Or I can use my slope formula. Remember, when you use your slope formula, you would say 2 minus 3 all over 5 minus 0. And that does equal a -1/5. That's my slope. Your y-intercept is where it crosses the y-axis. That was one of your perfect points there. So this is 0, 3. And we write our equation of our line in slope-intercept form. So y equals -1/5 x plus 3. And technically, I guess we could write our b value as that 3, the y value of our y-intercept. All right, so we've reviewed some key features: how to find slope, how to find y-intercept, how to create equations of a line. So let's compare those features now. So when I go to compare these features, okay, we can compare rates of change. Remember, the greater rate of change, or this rate of change, that's another name for slope. Okay. we look for the steeper line, or the slope with the greatest absolute value. So what that means, remember, when we look at greater, I'm going to type here, signs don't matter. So our signs don't matter. I'm not looking at the negative and the positive version of what I see here. I'm looking at the biggest number. Okay, signs don't matter. So we have a slope of -2 and a -1/2. 2 is greater than 1/2, so that's the greatest rate of change. Okay. Remember, maybe from middle school, absolute value just changes all negative numbers to positive numbers. We can compare input and output values. Remember, the coordinates on each line represent input and output. X values are inputs, Y values are outputs, and we can look at which function has a greater value when X is equal to 2. So let's do that. So when X equals 2, remember that this is your X-axis. So here's where X is equal to 2. I'm looking for the Y value of that point. So this point is 2, 0. Over here, again, this is the X-axis. So here's where X is equal to 2, but I have to look for the point on my graph. There's the point on my graph. That ordered pair is 2, 3. So which Y value is bigger, 0 or 3? Well, hopefully you notice that 3 is bigger than 0. So we would say that G of X has a bigger output. G of X is the correct answer here. Which function has a greater value when X is equal to 2? That's going to be G of X. Same thing here. We notice that f of x has a steeper slope, so that would be your answer to a multiple choice problem there. We can compare other things, other values, especially y-intercept. We can ask you which one's the greatest y-intercept. Remember, we're either increasing or decreasing. So when you have a negative slope, you're always decreasing. So let's answer this question here. What would the slope-intercept equation be for graph 1? So we have our y-intercept, and we can calculate slope. We've learned how to do that. So here we calculated, we're falling 2 and going to the right one. So my slope-intercept equation is y equals -2 x plus 4. Same thing here. We've identified some key features here, some input and output values. This is an increasing function, so my slope's going to be positive. I can find my y-intercept. So this is going to be y equals my slope, rise over run, 1/2, plus my y-intercept, which is at 2. So let's look at some things. When we look at these two graphs here, okay, which one has the greater y-intercept? So I'm gonna get out of this here. Which function has the greatest y-intercept? Graph 1 or graph 2? So we can say which graph. So let's look. We have a y-intercept of 4, and we have a y-intercept of 2. I can see that on the graph, and I can see that in my equation here. So graph 1 has the greatest y-intercept. What about the greatest slope? Also graph 1. -2, that 2 is still bigger than 1/2. Continue practicing comparing these functions on your practice activity.